Good evening. Let we start. Will not wait for other students. Okay. Sorry. Uh, Today we'll just complete this part. Whatever the STL program we are just taking, that we will try to complete today. Okay. So till today we have seen uh, what is that STL programming. Then we have seen one container, algorithm, and iterator. So these are the three components in that programming. So containers, these are the main, then algorithms, and then uh, iterators, right? So we have seen iterators, algorithms, and containers. I just told you, given the list of the algorithms here, which are the algorithms. And in last lecture we have seen how to use that iterator, and we have seen that iterator is the more likely to the pointer in C or CPP. Okay. So I'll just today I'll just tell you the two three containers. These are the sample containers. So the many containers are there. I'll not take all the containers because that is not our part. But the few containers I'll take, and with these containers you will know how to use the other containers. Okay. So I'll share my screen so that just tell you something. Okay. So yesterday I was having problem with that laptop. Today I have my own laptop, so I can explain you in better way. Uh, I'll just tell you which containers I'm just taking in this class. So what happened with this? Yeah, I think this pen is not working. 1 minute. Huh? I'll just pause this. See, pen is not working, but I'll just use that Jamboard again. Uh, Today I'll just take the three containers. One is the stack, that is the most popular container. Next one is the queue, and then list, right? So if you are having the idea about the data structure, so these are the data structures. Whatever the first we have seen, that is the vector, or in the C or CPP, that is equivalent like array. Only here we are considering the dynamic. So that is again a data structure. Here we are saying that is a container. Next data structure that we are taking here today, that is a stack data structure, or in this case we are saying that is a container. And next is the queue data structure, and then list data structure. So these are the popular data structures, and for all these data structures we have the inbuilt containers, and we can use these containers for the programming. But before that, you need to know, if you are having idea about the data structure programming, then this might be simple for you. But if you are not having the idea about the data structures, then you need to know first about the data structures. So I don't know how many people are having idea about these data structures or not, but still I just tell you in short about these data structures. So see, first data structure, that is a stack. So I'll just tell you what that stack would be. So this stack is like, see, this has one property, that is first in, last out, last out, right? This is the property of the stack. It means if you are having this kind of a stack, this is a kind of container, and we can insert the elements into the container from only single side, and this is this one, right? If you insert suppose first element into this, so that first element will goes to this location, and here we can say this is the top element, right? Now suppose I just wanted to insert again one more element into this container, so that is suppose 2. So when I insert this 2 into this, first I need to increment this value of this top here, so this top will comes to this location, and then I can insert the 2 into here, right? And the current value of this top would be this one, right? So in this way we can insert the elements from one side only, right? So as suppose I have just inserted 3 elements, so 1 2 3. So in this stack, whatever is the first element we inserted, that is 1, then second is 2, and then third is 3. Now suppose I just wanted to delete or just pop the element from this container, right? So how do I pop the element from this container? So see, from only one side we can pop the element. So whatever the element we inserted at last, that element we pop the first. So here last inserted element is 3. So when we goes for the popping or just deleting the element from the stack, so we pop this first, this 3, right? So when we just pop this 3, so that top will decrement by 1. So this would be the current value of top suppose, right? Now the next position of this stack would be 1 is at bottom and 2 is at here, and this is your top consider, right? Again, when we just want to perform the same operation on the same container, then whichever is the top element that we pop, so whatever is top 2 is the top element that we can pop, and we can delete this, and that current top would be this one, right? So it means from this the container, so we just observe whatever is the first element that we inserted into the stack, that we just pop the last element, right? And whatever the last element we inserted, that we pop the first. So that's why we are saying that stack property is first in, last out. Have understood this? So this is the property of the stack. But if you are suppose writing the operations for the stack in C or CPP, then we need to write the bigger code here. But if we are doing same operation in the STL, so we have the containers, right? So directly we have the function, using these functions we can directly perform these operations. So which operations we can perform here? First operation we can perform is we can check whether that stack is empty or not. First operation is empty or not. It means suppose this is the stack, right? And no element is here into the stack, and I am performing the pop operation. Suppose here I am just performing the pop operation, right? Now can I pop the element from the stack? Definitely not, because that stack is empty. So before just popping this, or before just applying this pop operation, we need to check whether that stack is empty or not. If it is empty, then we can say this is empty, and we can return that value. So in this case, we can return this value 1. So actually this empty and full, these are the two operations, and these are the Boolean operations. So second operation, that is the full, right? So when we can use the full operation, suppose stack size is 3, and we have suppose 3 elements into the stack. So 1, 2, and 3. So these 3 elements are there, and stack size is suppose 3. Size is 3, right? Now what we can do here, suppose I am just performing the push operation into this stack. but here that size of stack is 3 and all these 3 elements have been inserted into this, and suppose I am again inserting the fourth element into the stack, so we cannot insert because that size is overflow. So that's why before just pushing or inserting the element into the container, the stack container, we need to check this operation, this full operation. So whether this full, that stack is full or not. If it is full, then we cannot push any element into the stack. If that full is not, means if that stack is not full, then we can insert that element into the stack. Okay. So first operation is empty, second is full, then next is, we can say, push, and last one is the pop, right? So these operations we can perform on the stack. Now see, if I am just writing the code for push and pop, then I need the one entire function for that, pushing the new element into the stack and popping the element from the stack. So for that I need to write bigger code if I am using the other programming like C, CPP or Java something, right? But in this case, if you are using STL, so there are the ready-made functions are there, so we can use these inbuilt functions, right? So how these functions will use, that I'll just tell you. Okay, so this is the one container, right? So pushing is what, simply inserting the element into the stack, like suppose these are the element we inserted, right? And if suppose you want to insert any element into this, so if suppose that container is as, then you can say simply push suppose 5, right? So we can push that 5 here. And for popping this top element, simply we can say as dot pop, so whichever is the top element that will be popped, so this 5 will be popped, right? So if I am using this one, it means these simple functions are there, these two functions are there for the popping and pushing the element into the stack. So this is about the stack container, right? Now if you are writing the these operation using this STL, so code will be very small. That I'll just tell you, I'll show you that code also, I'll explain that also, right? Now next container that I'll just tell you is queue, right? So dictionary meaning of this queue is what, waiting line. So in this queue, I'll just represent this like this. This is a queue, and suppose these are the locations, right? So in this queue, we can insert the element from one side and we can delete that element from another side. So this is called as front and this is called as rear, right? So this is like a standing queue. So we can add the elements from this side and we can delete the elements from the rear side, right? Suppose I am just inserting first element into this queue, so that first element would be 1, right? 1 minute. Okay, ठीक है, consider this one, and these are the, right? So if I insert that element, new element into this, so my front value would be 0 and here rear value would be again 0, right? Because in this case this would be the front and this would be the rear. And if you see the second situation here, suppose here some elements are there, right? So 1, 2, 3, 4, 5 and 6, these are the element. Now in this case, this is front and this is rear, right? So here suppose that element is adding from the rear side and we are deleting that element from the front side. So if you are just applying that delete operation into this, so whichever is the first element that will be deleted, this element will be deleted, right? Then in this case, front value would be like say 0, 1, 2, 3, 4, 5, right? So now after deleting this, the first element, that front will be incremented by 1. So front will goes at the location 1, right? And rear will goes at location 5. This is as it is, right? Now again, suppose I am just performing the delete operation. So this will be deleted and front will be incremented by 1. So this front would be here. Now in this case, when I just delete that second element, so front location will be 2 and rear location would be 5 as it is. Now suppose I just wanted to insert any one element into this. So where I can insert, so this rear side I can insert. So here, suppose 7 element I inserted at 6th location, right? So after just inserting new element into this, so front is as it is because we have not performed any delete operation. So that would be 2 and that rear would be 6, right? So it means in this queue, when I just unqueue, or we can say add element into the queue, so that rear will be incremented by 1 and dequeue, it means delete. So when I dequeue, the elements of front will be incremented by 1, right? Or we can say front plus plus. And again we check here empty condition and full condition, right? So when I can check the empty condition and when I can check the full condition, so if suppose I am performing the delete operation and if no element is there, then in that case we cannot perform the delete operation. So in this case we can check this empty. So in case of DQ, we can check the empty condition. Full is what? If suppose that queue size is 4 and already 4 elements are there, and if I am trying to insert the one more element, that is fifth, so in that case I need to check that full condition. So here in case of NQ, so we can check the full condition, right? So this is the property of this queue. So queue property is what? This queue property is first in, first out. This one, first in, first out, right? So we can call this as FIFO, right? So FIFO. So first in, first out, this is the property of the queue, right? Again, that same thing would be there if I am suppose performing all these operation using the other programming. So I need to write the bigger code, but if I am using the STL programming, then here that for every operation that simple one line the function is there. Okay. Now next one, I'll just tell you this is most important, that is a list. This is actually somewhat critical if you are using that the normal C programming or the normal CPP programming, because whatever that stack and queue and vector we have seen, so in all these that memory allocation is in consecutive manner. Suppose this is a vector, right? This is a stack, suppose stack, and again suppose this is a queue. So you can see in these three data structures or in these three containers, that memory reservation is in sequential manner, right? So as we are just storing the elements in consecutive or in sequential manner, so if you are using suppose that iterator, in that case we can say that I plus 1 and I plus plus, that meaning would be same here, right? Yesterday we have seen what is the meaning of this I plus 1 and I plus plus. So when we say I plus plus, so that pointer will goes to the next iterator, and if that you are using I plus 1, then it goes to the next location. But in all these three container, in these three container, that meaning would be same, because that the memory reservation is in consecutive manner, right? But if you are using that list concept, now here just tell you the list. In list, that memory reservation is not in consecutive manner. So here that I'll tell you, this kind of the node structure is there. This one, right? So suppose the first node base address is 1000, then second might be 2000, that third might be 3000, right? You can see first node base address is 1000, second node base address is 2000. So this is not in consecutive manner. Around how much you can see 1000 difference is there. Then same thing would be in next one. And here whatever is this node structure, here this field is having that address of next node, and this field is having data part, right? Data part. Now data part, that might be integer, string, character, float, any kind of data you can put in this first block, and whatever is the second block, in this block we can have the address of next one. It means when I can say this is a linked list, so suppose that elements are this 10, 20 and 30, these three elements are there, and whatever this link part or address part of this first node, this will have value 2000, right? In second, that value would be 3000, and in last we can say it is null, right? Null, that is capital ASCII value of this null, that capital null is 0. That means last one is 0. So in short, this will be represented like this one, right? So this is again a sequential data structure, we can say. See, the data structure is sequential, but that memory reservation or allocation is not in sequential manner, right? Because that when we just read this linked list, so that reading is like 10, 20, 30, right? Similar to your array, that reading, if array is there, then 10, 20, 30, that the reading is in same way. But when we just say about the memory reservation, then in that case that 10, 20, 30, these are not stored in the consecutive memory locations, right? So this is the difference. Now here in this linked list, that first node address we required, it means for the first node we need one pointer, like suppose pointer, right? Or we can say this is the head pointer, head, or we can say start, any name you can give to this one, right? So once we have that head pointer, start pointer, or pointer, so once we get that first node, then we can get all these nodes, because whatever is the name of this field, I'll just tell you. Suppose start, I'll just take it. Okay, start pointer I'll just take. And one more again thing you just consider, here for every node that multiple pointers are there. So if I'm taking that start pointer for the first node and that PTR for this traversing, so here we can say PTR of data, that is 10, and PTR of suppose address, this is 2000, right? So it means I need to think about this data part and then address part also. But if suppose I am not using this the C or CPP or Java, if I am using STL, so not necessary to think about all these address and something, because we have the inbuilt functions here, right? So here, suppose I just wanted to insert, but if you are using suppose that what we say that STL, then in this case, so whatever is the pointer here, that is the begin pointer, right? And whatever is the pointer to the last one, that is the end pointer. And here, as we know, we need to write that the uh, container name or iterator name before this. So if you are using the iterator IT, so you can write here, and before this begin also you need to write this IT. Getting this? So it means if you are using that list, then here also I can use this STL. If you are using stack, also we can use STL. If I'm using the queue, DQ, priority queue, whatever, all these containers we have. So for all these containers, I can use the STL programming. So I'll just tell you in short how this would be so that you will understand it. Whatever the theoretical concept I just told you, these are just for the understanding the concept. But if you are writing the program for this, so only if you are having the idea about the operations, then we can write the STL program for that same. Okay. So this was about the something about these container. I'll show you now the examples for these, and I have the programs here. I'll just show you, right? Now we'll see about the first container, that is stack. This is stack is very simple. I'll explain in short because this one would be the very simple. As we know, the stack is the container of type integer, and I have just created this one, right? S. So using this as, I can access whatever are the functions related to that stack. I can access all these functions. So here s dot push, that is for the inserting element into the stack. So whatever is this first code, that is for the inserting the element into the stack. And see here that size function is also there. I can find out the size of the stack using this size, and also I can check whether the stack is empty or full. And I said that empty and full, these two functions are the boolean functions, so that output would be true or false, or we can say 0 or 1, right? So this is the simple program using STL for the stack. I'll just show you here that output also. I'll just copy this and we'll paste here so that you will understand. You can see that same code I just copied here into this, and if I run it, so what is expected output here? So 5 elements are we are inserting into the stack. So 1 2 3 4 0 1 2 3 4 5, these till 4, right? And that size would be 5, this output would be 5, and it is say if it is not empty, then we are popping it, right? So if you run this program, you can see that size is 5 and the elements are 4 3 2 1 0. Why that order is in reverse way? Because we are popping it. So which element we pop first? Whatever is the last inserted element, that we are popping here first, right? You can see here we are popping, displaying and popping. So in this case, first element that inserted is 0, that second is 1, then third is 2, then fourth is 3, and next one is the 4. So it means whichever is the recently inserted element, that I'll pop first. So 4 element we inserted recently, so that's why we pop first 4. So 4 3 2 1 0, like this. Have understood this? So this is about the stack, and we can use that the You can print this empty also, but this will be the boolean output. Okay. Now next one is the queue. As I said, in queue, that first in first out, that concept is there. So I'll show you this. You can see here, whatever is this code is for the displaying the queue, right? So to display that queue elements, we are using this function. So here we just created this container, that C, of type integer, and if it is not empty, then we are simply printing the front element, right, and popping it. So in main program, we can see here, for the queue container A, that is of integer type, so we inserted 10, 20, 30. These three elements we just inserted into the queue. So first element that we inserted, that is 10, it means that is a front element, right? Next is 20, so that is rear element. Again 30, that is rear element. So after just inserting these three elements, so front value or front element would be 10 and rear element would be 30, right? So if you see here, using these functions, we can display this 10, 20, 30. This queue will be displayed. And here a dot empty. So whether this stack is empty or not, so this is not empty. So we can say, if it is true, then we can say that is 1. If it is false, then we can say 0. As that as this queue is not empty, then that value of this empty would be 0. Then size would be, so whatever the size, so 1, 2, 3, so that would be the size of this one. Front element, we can say that is 10, and back element, that I am saying, that is a rear element, so that back is 30, right? So with this, that output would be 0, then 3, then 10, and then 30, right? Now here I am just applying, suppose, pop operation. So pop the, after just applying this pop operation, whatever is the front element, that would be popped. So front is what, that is 10, right? So that will be popped. So after just popping that 10, so that display is what, that is 20 and 30. Only two element would be there, that is 20 and 30. And again, suppose I am pushing the next element into this. So where I can insert, so at the rear end I can insert, so it means after 30 I can insert this 40. So when I display this queue, so that queue would be 20, 30 and 40. So I'll again do the same thing. I'll show you here. I'll just copy this part and I'll just run this. So that I'll just minimize this time, right? So I'll run this. You can see here. Yes. So see, the queue elements are 10, 20, 30. As I said, if as this queue is not empty, so empty value is 0, right? If that queue is empty, then that value would be 1. So this is a boolean, the output 0 or 1. Then size, I said this is 3 because 3 elements are there. Front element is this 10 and rear element or back element is 30. So here, now if I am performing the pop operation, so whatever is the first element, that is front element, that will be pop, that is 10, and that the remaining are 20 and 30. Again, if I insert this, the one more element into this, that is 40, so I can insert that 40 after this 30, right? So here that output is 20, 30 and 40, right? So this is about the queue. If you are having idea about the operations on that container, then the functions are inbuilt. We are not code anything into this. If you see this, simply we have just used the functions, right, in this entire code. Now next is list. So I just told you what that list is. Only this is the linear data structure, but that memory allocation is not linear. You can see here. So in this list, we just use that iterator because already I just told you here, I think into this, right? So these are not in consecutive manner. So here I cannot use iterator plus 1. I need to say it plus plus so that that pointer will go from this 1000 to 2000, right? So what I did here, I'll show you. So we have created this list like 1, 1, 2, 3, and 5. So these are the elements into the list. And how do I display this list using iterator, because I cannot use that simply the array kind of thing here. I need to use pointer to display this. This is a fixed thing into this. So I just created one iterator, that is it, right? So it equals to mylist dot begin. So assigned this iterator for the first element. Now it is not equals to mylist dot end. Till that we need to continue this loop and plus plus it. And here we know how to display these contents. So star it that we can use here, right? So I'll just show you this also to this. Already I have just done this. Here we can put this bracket, not it is mandatory, but I'll just put because last lecture we have just used this same syntax. If I run this, you can see 1, 1, 2, 3, 5. So these are the whatever the list, that same list we just displayed using the iterator. Okay. But suppose I want to perform some addition operation on this. How do I insert? I'll just tell you this insert also. First, I'll just explain here. Suppose that list is there. So I have created one iterator, that is it, that is assigned to the first element into this, right? Now suppose I just wanted, consider this one, right? Your pointer is at suppose this location and I need to insert one element after this 30. So what I need to do here, I need to take one pointer that would be assigned to the first element and I need to traverse or bring that pointer to the last node. Suppose here, consider that iterator is here. Okay. Now how I can insert, I'll just tell you in short here. 1 minute. Suppose this is the list. Okay. 1, 2, and 3. Suppose this is the begin. I have taken, this is the end, and I have taken that iterator, suppose that is it that we brought here, suppose, right? Now one, whatever the new node, this is a newly created node, suppose that pointer is stamped to this. Consider address into this is 3000 and here base address is 4000, right? So our aim is what? Our aim is to create this link here, right? So to create this link, I need to store this 4000 instead of this 3000 here, right? So how I can do this? So I can say here it of address that would be equals to, right, this temp, right? So temp value is 4000. So this is temp. How that temp value will be 4000? Because whatever is the memory block reserved for this temp, so that temp value, that base address will be stored here. So with this I can assign, suppose this is 4, assign this 4000 into this and I can create this link, right? So here for that you need to understand only that operations. So first step is I need to bring this to the last element and then I can assign this or I can create this link, right? So this one is the required only into this. If you see this here, I'll show you in bigger one. See, this is the list 1, 1, 2 and here I have created one iterator, that is IT, assigned that to the begin. Now 1, 2, 3. So these are the three elements are there into the list. So 0, 1, 2. These are the indices. So at third location, means at third index, actually that is the fourth location, I need to add one more node, right? Suppose that node I am just trying to insert, that is 5. So how do I bring this? See, so to bring this IT here, this one, right? IT here. So that function we have as this advanced IT3. You can see here. So advanced then IT3. So this will bring that IT iterator at this location, and then there I can insert the. Oh, feels like much time. Hmm. You can see here. So that list elements are before just inserting. at front and back, that list is 1, 1, 2, 3, and list after pushing, push front and push back. So here 0, 1, 1, 2, 3, and 5, right? So these are the operations. The other operations are also there on the linked list, so that you can try at your home. Okay, so this was, I think, about the pushing and pop front and pop back is again same. I'll not write anything here, I'll just explain you that similar to that. You can see here that pop front and pop back. So if suppose this is a list, so if I say pop front, so that 1 will be deleted. If I say pop back, so that 5 would be deleted. That is the only thing here, and we can display that same list. So this is the same function to display the list, right? So this was about the iterators or iterators, we can say, right? So if any doubt, you can ask me, please. So anything, if any doubt, you just ask me.